Hi, thanks for joining. My name is Jagadeesh. I'm going to talk about a machine learning program which can predict the currency conversion rates given the historical data. The use case is mainly if you can predict currency conversion accurately, that will actually help international banks and also global trade organizations to handle their business efficiently. So mainly I have gathered the data set from Excel rates and then massage the data to remove some anomalies as well as um, restructure the data so that I can use for the model. Now there are other sites where you can get this data by paying. Now I chose this one for this project because it's freely available for the exercise. Now you can see here that I have used some data transfers to actually convert the data or remove the anomalies within the data. So on the left hand side is the actual data I got from that site. Now if you actually look at it from 1999 to 2008, the data is missing, and if I develop the model on this data, then the results will be skewed. So in order to have a good prediction, so I massage this data to remove this particular bad data, and then once I remove the data, then you can see here that um, all the data points data set are currently valid. Okay, now I used LSTM model for prediction with 3 layers. Okay, and uh, in that, okay, I also used MAE loss function to actually assess the loss. So the reason I chose LSTM is LSTM is the preferred method for a time series prediction. Now, if you look at the exchange rates, the prediction model that I'm I implemented is mainly for a time series use case. So for that, LSTM is one of the preferred approaches, and as, as part of this model, setting the parameters is one of the key. Now, I tried several performance parameters to come to the reasonable value for the given data set. Actually, if you look at here, during if I when I started with 120 iterations about, you can actually see that after it started looking, if you look at the loss, okay, this is the epoch 0, epoch 1, 2. So you can see that the loss is 0.2, and gradually it came down to 0.04 around epoch 2021. After that, it didn't really reduce much. Okay, it stayed as it is until to the epoch 220. So I got my best result around this region of epoch um, 20. Okay, so further tuning would have not helped, okay, in this case. So let's see all of this in action. Okay, this is my Jupyter notebook on IBM Watson Studio. So you can see here, like the use case is the actual title of the project is predicting USD to INR currency conversion rate. So why is the currency conversion important? Okay, so most of the international transactions goes through this currency conversion, and it's not a constant value. Okay, like a stock market, there's always fluctuations in this. Now there are several factors that impact it, but predicting this based on the historical is definitely a good start. Okay, now it's going to when you predict a currency conversion, it helps a lot of businesses, especially the banks and trade and things like that, to make the decisions based on this. So it can be used in the decision making. Okay, so the profit margins and customer satisfaction and all those things are dependent on some of these currency conversions. Okay, when you are dealing with international transactions, so offering this as a service in the cloud with a very good production rate is going to really help the businesses. Okay, so with that, so for this particular exercise, I just took the data set from the exchange rates. So this is the website. I got it. I got the data from 1999 to 2020. There are other websites which have a lot more reliable data, but they're all paid. So for this exercise, I just got the free data set. Now, after that, I did install TensorFlow 2.2. Okay. I also uploaded the downloaded data set to the Cloud Object Store. You can see it here. And I just used the snippet, Cloud Object Store snippet here to actually load the data. You can see that when I execute, this is the data set structure. Okay, it has a date, USD, and INR. Okay, this is mainly conversion from USD to INR for every day from 1999 to 2020. Okay, now you can see that it has 3 dimensions. Okay, so I want to actually visualize this data and see how this data looks like. Okay, so you can see here from 1999 to 2008, the data is bad. Okay, it has some anomalies. Okay, so actually the INR value is 0. Okay, so the data is not even valid. Okay, so if you train your system with this kind of data, you will skew results. Okay, so the data cleaning is a critical step in this case, and also I don't need the USD value because it's always 1. Okay, so because I'm actually predicting INR, so I don't need it. I can always take that 1. Now I'm going to describe this data before cleaning and see how it looks. Okay, so this is how it looks. Now the next step in the process is ETL, where I'm going to actually, in the first step, I'm dropping the USD dimension, and also I am deleting all the INR which have 0 value. So that reduces my data set, but at least it makes it cleaner. Okay. So then now I'm actually going to try the visualization and look at my data to see how it looks. See, now it looks clean. So now we are ready to move forward. So I'm going to do the next feature creation. So with this, you can see here I'm initializing the batch size 64 and epochs 120. So, and I'm going to calculate the length by keeping 10%. And this is the training length of 10% for the testing. So now you can see here the length is 3765. That is the actual 90% of the data set that I'm going to use for my training. Okay, so and also the time step is an important parameter that you need to calculate. So take the length and divide by the batch size. You will get the time steps. Now in this, using that length, I'm going to actually divide my data set and get the data set to that size. Okay, so I'm going to use this data set and I'm actually going to transform this. Okay, as well. So I'm using here min-max scalar pre-processing, and I'm transforming my data set in here, data set here. You can see that that's transformed. Now the model I'm using here is LSTM. So why did I pick this model? Okay, so LSTM is the best model we have for time series based machine learning prediction. Okay, so that's the reason that I picked for this problem, LSTM. And also I'm going to use create 2 models in this case, one with MAE loss function and MSC loss function just to compare. Okay, so here I'm building the model. You can actually see that I'm adding multiple layers. There is a initial layer, two LSTM layers, and the output layer is dense. Okay, so I compile the model and I'm printing out the summary here. So I'm using the optimizer Adam in this case. Okay, so this is the model summary. So similarly, I'm building another model here for MSC. Okay, everything else is same. Okay, just for comparison. Now the next step is so I'm using a stateful LSDM here. Okay, because this is a prediction that it needs to actually learn over a period of time and then predict. Okay, so so I'm using a stateful LSTM model here. Then in the next step, I'm going to fit the model. Now, the one thing is fit with the training set. So one thing is this is going to take a while. Now, I mentioned that the tensor, it's better to install the tensor flow 2.2. The reason is when I have not done that, this step used to hang. Okay. So after I did tensor 2.2 install, the step completes in a few minutes, okay, on a 1 CPU, 4 GB environment, okay. I'm going to start this, okay, there are two fixed methods I'm going to execute, okay. So it's going to take a while to complete this because I'm running for 120 iterations in this case. So it's going to take a while, okay. So for that reason, I'm going to pause the video temporarily and we'll come. Hi, welcome back. So the process is complete now, okay. So let me share my screen again. So we did fit both the models. Now I'm going to evaluate the models here, okay. So I'm going to actually construct the test set, okay, which is 10% of it, which is around 256 entries in the data set, okay. So I constructed the test set, okay. Now I'm actually going to validate it. First, the MAE model that we did. So you can see that I reshaped it. Okay, so I tested that, and I'm going to graphically visually represent that model. So you can see that that red line is the actual real value, and the predicted value is very close to the red line. Okay, so it is following the same curve. So the model has really predicted really well in this case. So what about the MES using MES loss function? Okay, so let's see. So this is the representation for the second model. That just the loss function is different. I'm actually going to calculate the mean absolute error and mean squared error. You can see that 0.31 and 0.39 is actually less than 1. Okay, so which is actually a pretty good, looks like pretty good data set in this case. Okay. So now I'm actually going to do the mean and check. Okay, it's like 0. So mean is 47. Okay, and MAE mean is that, and SC mean is 0.82. Okay, so pretty close. Okay, in this case. Okay, which is less than 1. So that is the prediction. So basically, using the data set that I got, I was able to actually successfully train the model and predict. Okay, so thanks for watching and have a good day.